Illustration of longest common subsequence. In the last lecture, we learned about longest common subsequence problem and the algorithm that can be used to solve this problem. What we are going to do in this lecture is we'll see how exactly is the dynamic programming table filled for solving this problem. We know we have to start filling from the first block. We have to keep filling this block till we reach the final block. Whenever you reach the final block, that is when you will know what is the length of longest common subsequence. Let us see how each of these entries are filled. This will give you a complete picture of how exactly this algorithm is working. We'll take an example, we'll take two strings and understand how each entry is filled. Let us start with this. First of all, we'll see the algorithm. We already learned algorithm in the last lecture. We are just having to take a look back at it. You have a string x. Let us say x is a string of length m, which means x will have entries 1, 2, 3, 4 up to m, or you can say x1, x2 up to xm. This is what is called as string x. Similarly, you will have a string y which has y1, y2 up to yn, which means n is the length of string y. What do you want to do now? The first step in order to find out the longest common subsequence, that is here, what is this x1, x2, etc.? Let us say x is a string a, b, c, d. Then a is your x1, b is your x2, c is your x3 and so on. So this is how two strings are formed. What do you want to do in the first step? The first step is you want to form a two-dimensional DP table. So you want to form a DP table. I'll write create DP table. What should be the size of this DP table? You have m as the size of string x and n as the size of string y. So your DP table should be having a size of m plus 1 cross n plus 1. This should be the size of DP table. And what does each entry in the DP table signify? If you have an entry DP of ij, then what does this mean? This particular entry mean it represents the length of longest common subsequence formed using the prefixes x from 1 to I and y from 1 to j. What does this mean? At this point, you are only considering the first I letters of x and first j letters of y. Considering this much of x and y, what is the length of longest common subsequence? That is what dpij will tell you. One more thing, at this point, what will be the index of x? Even though I am saying it is from first element till the ith element, the index of this element will be x of I minus 1. Why is this I minus 1? The reason is indexing always starts with 0. So if x is your string, let us say a, b, c, d. This is your string x. Index of a will be 0. Index of b will be 1. Index of c will be 2. And that of d will be 3. So your fourth letter will be at index 3. So just keep this in mind. In later when we are using it, it will be useful. So at this point, you have created the DP table. What is the next step? Next step is to initialize your table. How will you initialize? Fill the first row and first column with zeros. So fill your first row and first column with zeros. This is your next step. Once you fill this with zeros, next step is the most important step. What are you going to do? For each of the entry in this matrix, you want to fill it. How are you going to fill it? If it is the case that for that particular block, if x of I minus 1, if this is equal to y of j minus 1, if both the characters are matching, in that case, what will you do? You will say dp of ij, which is the entry to be filled. This will be equal to 1 plus because you matched, you are increasing the length of subsequence 1 plus whatever is the longest subsequence using one letter short from string X and one letter short from string Y. So that can be represented as dp of I minus 1 j minus 1. So this is how you represent this case. What is the other case? Else case. Else, that is in case x of I minus 1 and y of j minus 1 are not equal, the letters in the strings don't match. Then what did we do? What did we learn in the last lecture? You have to take maximum of two cases. What if x is as it is and y is having one letter short? And what if y is as it is and x is having one letter short? Both the cases you have to consider, and whichever is giving you the maximum value, that is what you should take. So one will be dp of I minus 1 j. That is if x is having one letter short and y is having all the letters. All the letters means up to jth letter. We are only considering till jth letter in y and till ith letter in x at this point. So one is this and the other one is dp of I j minus 1. What does this signify? This signifies x is having all the letters till I, but y is having one letter short from j. This is what it signifies. So this is your algorithm. Once you complete this, you follow this and fill each and every entry in the table. Whenever you complete, what should you do? Fourth step is you should look at the last entry, that is dp of mn. Whatever is the last entry in your dp table, that will be having the length of LCS. And at the end of this lecture, we'll also see how to backtrack and find out the actual longest common subsequence. That is not just the length, how to find out actual subsequence. So let us start with this. We'll have two strings. Let us say your string x, let this be string x is equal to runner. Let this be your first string. And what about the second string? Let us say your string y is underdog. Underdog is your next string. You are going to find the longest common subsequence between these two strings. Underdog. This is your second string. I'll just put indices to these so that you'll understand what are the index numbers. While comparing, this will be easier. So 0, 1, 2, 3, 4 and 5. These are the indices. What about y? Y is also, let us say this is the string underdog. Underdog is having indices 0, 1, 2, 3, 4, 5, 6 and 7. We are going to find the longest common subsequence between runner and underdog. Let us see what is the longest common subsequence here. What do you want to do first? You want to form the DP table. Let us say underdog is here. Underdog. Underdog. And the first one I'll put as 0. And what about the other string? It is runner. 0. Then I'll put runner here. R-U-N-N-E-R. So my string runner is here. Then let us draw the DP table. This is a DP table. We are going to fill entries one by one in this DP table. And whenever we reach the last entry, that is when we'll have the length of our longest common subsequence. After that, we'll also see how you can backtrack from this and then find out what exactly is the longest common subsequence. That is not just the length, you'll be able to find out which exactly is the common subsequence. So this is our DP table. So instead of indices, I put the letters itself so that it will be easier for you to compare and identify. Okay. What is the first step? Let us go to the algorithm here. What is the first step? You have to create the table. Yes, we created the table. What is the next step? Next step is to put first row and first column as zeros. Let us do that now. So I'm taking this table. Let me put all zeros in the first row. Why is it all zeros in the first row? The first row says the length of your string x, that is here it is x, here it is y. Your length of string x is 0. So if one string is of length 0, that means the maximum length common subsequence it can have with any other string is of length 0, because this string itself doesn't have any letters. That is why first row is 0. Similarly, first column will also be 0, because that represents to the situation when your string y is having length 0. If the length of string y is 0, it cannot have any common subsequence at all, because it is not having any letters in it. What about the next step? Let us go back to the algorithm and see the next step. Next step is, for each of the block, you have to see whether x is equal to y. That is, the letter corresponding to xi and letter corresponding to yj or xi minus 1, if you consider the index, are those letters equal? If those are equal, then you have to take 1 plus dp I minus 1 j minus 1. What is I minus 1 j minus 1? If you are standing at any position, I minus 1 j minus 1 position will be diagonal to you. That is what is one row less, one column less. So it will be diagonal to you. Otherwise, that is in case it matches, you have to add 1 to the diagonal element. Otherwise, if it does not match, what do you have to do? You have to take the maximum of dp I minus 1 j. Where is I minus 1 j present? I minus 1 means one row up. What about j? J means same column. So you simply have to see which is the element right above it. Or what is the other case? dp I j minus 1. That is same row but one column less. So in the same row but one column less. In that case, you have to see whichever is the element on the left. So there are two cases here. In case the two letters match, what will you do? You will see which is the diagonally above element. Using that element, you will add 1 plus the value of the diagonal element. In other case, if the letters don't match, you will see what is the element above it. You will also see what is the element left to it. Among these two elements, whichever is the larger, the maximum element, that is what is going to be inserted. This is the logic. So let us use this logic and try to find this table. Let us try to fill this block. So while filling this block, one letter is U and the other side is R. You have R and U. Are they equal? They are not equal, which means you have to see the block above and the block on the left. Both are zeros. So maximum among them is 0 only. So you have to write 0. What about the next block? This block is having N on one and on the other it is R. These are not matching. So you will check the block to the left of it and the right up and the one on the up of it, top of it. Among these two, whichever is the largest. Both are zeros. So you will write 0. So the same case with D, same case with E. But then here R matches. So this is interesting. Whenever you find a match, what do you want to do? You have to see that element diagonally above it. That is this element. From the element which is diagonally above, what do you want to do? You want to do 1 plus whatever is the value of the element diagonally above. So 1 plus 0 is 1. This is the value here. What does this mean? If you consider the letters till R in string Y and letter till this R in string X, that means X is having only one letter R and Y is having U, N, D, E, R. If you consider this much, then longest common subsequence is having length 1. That is, here it is R, here also R is present. It is the longest common subsequence at this point. That is what you know. What is the next step? You will keep going forward. R and D does not match here. What will you do? You will see the element on top. You will then see element on the left. 1 and 0. On the left you have 1. On top you have 0. Which is largest? 1 is largest. So you will take 1. Similarly, you will have 1 for O, 1 for G. Using the same logic, let us fill the complete table. Here U and U matches. what will you do? You will see 1 plus diagonal element. Diagonal element is having value 0. So 1 plus 0 is 1. What about u and n? They do not match. You have to see the element on the left and the element on top. Among them, the element on left is 1, which is the larger value. So you will take 1. What about u and d? For this particular block, u and d does not match. Same logic, you will have 1 here. Let me redraw this one. Next is u and e. U and E again does not match. So you will see what is on the left and what is on top. Among them, on left you have 1 which is largest. So you will put 1 here. What is the next step? Similarly, you will keep doing for all these. Now on top also you have 1. On left also you have 1. So it is 1 only. Whichever is the largest, that is what you will use. So again, all these do not match with you. So you are putting 1. Next row. N and U does not match. So what will you do? You will check top row, top block and left block. Among these, top is having larger value. You will put 1 here. Next one is interesting. N is matching, which means you should do 1 plus diagonal element. What is the diagonal element? Diagonal element is having value 1. So you will do 1 plus 1, which is 2. So you have 2 at this point. What about N and D? They do not match. You will copy from left side. Again, you will copy from left side, left side, left side, left side and left side. Because all these do not match with N. So at this point, you are filled with first 3 rows R, U and N. Next row, again R and U here does not match. What will you do? You will see the block on top and block on left. And 1 is the larger value, you will put 1. Next one, you are having N and N. So N and N are matching. What should you do? 1 plus diagonal element. Here you should not look top and left. Instead, you should do 1 plus diagonal element. What is your diagonal element? Your diagonal element is 1. 1 plus 1 is 2. So the value here is 2. What about N and D? N and D do not match. So you will see top and left both are having 2. So you will write 2 here. Similarly, N and D do not match. N and R do not match. Do not match. So all these do not match. So I am simply writing 2 all over. Next is E. Coming to E, E and U do not match. So you will write 1 here, copy it from top. E and N do not match. So you will write 2, copy it from top. E and D, they also do not match. So you will write 2, which is again copied from top. What about E and E? Here you have a match. So whenever you have a match, what should you do? You should do 1 plus diagonal element. So 1 plus, what is the diagonal element? 2. So it should be 3 here. What about the remaining ones? There is no match. So I'll just copy this. Next one. Next is the last row. So this will tell us what is the length of longest common subsequence. What is the letter here? It is R. Is there a match? No. So I'll put 1. Then I'll put 2. So here I'm copying from top because that is the largest. Whenever you get a match, here you have a match. R and R are matching. What should you do? 1 plus diagonal element. So your diagonal element is 3, which means your answer should be 4. Again, R and D do not match. So you copy 4 from left. R and O, they also do not match. What will you do? You'll copy 4 from left. R and G, again, do not match, which means you will copy 4 from left. So what did you have as the final answer? The final answer that you have is 4. This means the length of the longest common subsequence among runner and underdog is 4. So this is how you actually go through and fill the dynamic programming table. In practice, you are not going to manually fill. Instead, you will write the code and the computer will fill it for you. But you should know how exactly is this getting filled. Then only you are good enough to write any algorithm. That is why I did it manually and made you understand how exactly each of the entries are getting filled in the DP table. Okay. So the next thing is, now we understood how the table is getting filled. One more important part is, once you fill the table, if someone asks you, okay, longest common subsequence is having length of 4, but what is the longest common subsequence? You should know this. So in order to know this, in order to backtrack and find out the longest common subsequence, let us see what is the procedure. See, one option is whenever you see a match when you're filling the table, you can note those letters down. That is one option. Otherwise, if you have the complete table filled, someone gave you this DP table and you want to backtrack and find out what is the longest common subsequence. For that, I'll show you the procedure. The procedure is, first you have to start from the last block. While you were filling, you started from the first block, but this time you are backtracking. So this is backtracking algo, okay? Backtracking algorithm. In order to backtrack, you should start from the last block, that is dp of m n, whichever is the last block, this is where you should start from. Then what should be your first step? Your first step should be if the letters match, that is if xi minus 1 and yj minus 1, both the letters are matching, in that case, you know you took the diagonal element and added 1 to it. This is what you know from the algorithm that you learned before. So what should be your backtracking algorithm? You should include this particular character which is matching, and then you should move to the element that is diagonally on top. So the second step is, here there are two subcases. One subcase is if the letters match, that if xi minus 1 is equal to yj minus 1. If this is the case, then what should you do? You should include that character in LCS. LCS, let us say you have a string called LCS, which you are building now. Include this particular character in LCS and then move to the diagonally top element. That is, you should move to dp I minus 1 j minus 1. This is where you should move to. You are presently in dp ij. From there, you should move to dp I minus 1, j minus 1. So you are doing reverse of whatever you did previously. Otherwise, else, if these do not match, then what should you do? Among dp I minus 1 j and dp I j minus 1, whichever is larger, you should move to that block, because you know whenever there wasn't a match, what did you do when you wrote the algorithm? You picked whichever is the largest element among the block on the left and the block on the top. So this time you are doing reverse of it. That is, you will see dp of I minus 1 j and dp I j minus 1. Among these, whichever is the larger element, you will go to that particular block, but you are not going to put it in LCS. This is the point here. Here you know there is no match between both the strings, so you should not be putting this letter in the LCS. What is the next step now? So you have to repeat this. Repeat this step until you reach dp of 0, 0. That is when you know you have to stop. But is the job done? No, wait, there is something more. The last step is, when you did this backtracking, you got the LCS string. But the problem is it is reversed because you started from the last and went to the top. Instead, what should you do now? You should reverse whatever you got as the LCS string. So you reverse the LCS string to find actual LCS string. Let us put this algorithm into practicality. Let us try this on this table. Let us see if we can find out the longest common subsequence. You already know it is having a length of 4. We are going to try and find out what exactly is the longest common subsequence among underdog and runner. So here it is 4. If you see the letters, one is G and the other is R. So R and G do not match. So see the top block and left block. Whichever is larger, move to that block. But do not include anything in LCS string, okay? So you are moving to the larger one which is on left. Again, O and R, O on top and R on the left, they do not match. What do? You again see among top and left blocks which is the larger one. So 4 is larger, you will move to 4. Again, here it is R and D, they do not match. So again you will move to 4. Here it is interesting again. R and R have a match. So what do? You move to the diagonally top element, that is this one, and you will record this particular letter as a member of LCS. So here the letter is R. So you will have R in the LCS. What is the next step? Again, you will see here for this block of 3, E and E does match. What do? You move to diagonally top element and you record that here, RE. These are part of LCS. Again, N and D do not match. What do? You will choose whichever is larger among the left block and the top block. Here both are same, so let us say I am moving to the top block. Here D and N do not match. What do? Again I choose the larger one, which is 2. This time N and N is a match. So I'll add N in the LCS and what do? I'll move to the diagonal element. Again U and U is a match. When it is a match, what do? I'll move to the diagonal element. So after this I'm going to reach this one. So this is the end of our LCS algorithm. What do you have now? You have the LCS string but in reverse order. So what is the actual LCS string? It is U, N, E, R. This is your LCS string. Let us just verify if the string is the LCS. Your first string is runner. So does this have U, N, E, R as a subsequence? Yes, you have U, N, E, R. So U, N, E, R is a subsequence of your first string. What about the second string? U, N, E, R. Yes, U, N, E, R is a subsequence of your second string as well. And if you verify, you will understand that U, N, E, R, which is a 4-lettered substring, is the largest possible or the longest possible substring for these two strings. So this is about the LCS algorithm. What about the time and space complexity? Even though we already learned in the last lecture, we are going to emphasize again, time complexity is order of m into n because you are filling a table which is of size m into n. And what about the space complexity? Space complexity is also order of m into n. And there is one more thing now. You have a space complexity of order of mn now, which is because of the table you are using. Can you optimize this a bit more? That is, from order of mn, can you bring the space complexity down again? It seems that it is possible, and in the next lecture, we'll see how to form a space optimized dynamic programming algorithm, which will bring down the space complexity from order of mn to order of n, or you can say order of minimum of m and n. So let us see how that algorithm works in the next lecture.